As you may remember, in one of our last exercises, we just created a collection object for person objects. Remember, a collection object means it is a handful of data that allows us to load a handful of data out of the database, where normally not the complete data it's loaded. We load only a foreign key to a single object, plus we load a display. To do so, we can just define a query. You can see that here on the screen. It's our QPerson query, and that query defines which table to ask, which is the table person. It says load the standard display, which is defined as well in the database, and then we can configure as well a where clause. And this where clause allows us to load a specific subset of data. In the past, in our old script, we just created a SQL statement and used that SQL statement as a condition. Unfortunately, creating a SQL statement is sometimes not really helpful, especially because there are Oracle systems in the world, there are Microsoft SQL systems in the world, and all of them are speaking SQL. You know, SQL is a standard, but unfortunately, SQL is not equal to another SQL, as we all know. And so it might be helpful to find something that creates the right SQL for the right system, which is part 1 of the argumentation. And part 2 of the argumentation is that if you use SQL and if you get input from the outer side, that people can add sensible values in fields so that our statements are working with the right values, but they can as well, for example, in parentheses, add SQL commands into an input field. Yeah, there is a last name field, and the last name gets configured from a person on the outer side, and instead of typing in there Abele, for example, which is a last name, they can type in something like, in parentheses, like drop database and the database name, and if this gets executed by a SQL executor, then the complete database will suddenly disappear from your server. Such kind of stuff, it's named SQL injection, and it is important that systems gets hardened against these type of SQL injection as well. Therefore, in our identity manager, we use the SQL-Formatter. You can see it on the screen. There is a variable f defined as an SQL-Formatter, and that is based on the session. This SQL-Formatter allows me now, for example, to combine 2 subclauses. There is a comparison for first name that looks for a like of each people starting with an H and on the first name side. You can see that it is first name, the term that gets searched, it's age percent, it's a wildcard, and a little bit on the end of the statement there is compare operator like, and configures this substatement in a way that there is a like comparison handled. Then there is a comma, and we see another subcondition, and this subcondition say last name Abele. In reality, this is the same like a SQL statement that says last name should be Abele and first name should start with an H. The whole thing, as mentioned, it's built with the help of a SQL-Formatter, and this SQL-Formatter now is on the session object which type of database it is, and so the result for an Oracle system will look a little bit different than the result for a Microsoft SQL system. At the end, and that is something you can then see if we test that script, this SQL-Formatter will generate a SQL object. And if you look now into this result set after I started the browser, you can see that the system is building a SQL where clause. The SQL where clause says now exactly what I mentioned, first name like age percent and last name like Abele. That is what this specific SQL-Formatter does. And I'm sure it's now safe, and I'm absolutely sure it will work with Oracle as well. The whole thing goes then into that specific QPerson query, and from there I can build my collection object as we discussed this before.